Today I'm going to be demoing my Minecraft bot I've been working on for the last couple weeks. I've got one of my accounts here on just a server running on my computer. Right now I've got him set to follow me around. He's just looking at me, but when I step outside of the range, he'll immediately pathfind to become closer. The pathfinding is based on A star. The A-star algorithm just really works on nodes, so it was fairly easy to implement it in a 3D world like Minecraft's. There's a lot of checking going on whether or not this is a solid block or not, whether or not it can step through it. And I'll give some demonstrations later of it solving mazes and stuff like that. It's really fun to watch. Right now, I'll kind of guide him over here to this little demonstration platform I have set up. It's just a large block of, stone, normal stuff you might have a bot mine for. He's having a bit of trouble pathfinding over here. Let's get him a bit. There we go. Here's a pickaxe. Now I'll tell it to mine this area. It gets to work. I haven't yet implemented breaking blocks in the pathfinding yet, so sometimes the bot has a bit of trouble getting up to places like this, so I'm just going to help it out for now. This is definitely something I want to improve in the future when it comes to the pathfinding, but for now, I think the way it moves is acceptable. The bot has an understanding of its inventory and how to use tools. That's a calculation that has to be done on the client side, how long it takes to break blocks. Every block in Minecraft has its own hardness, and the tools have different efficiency modifiers. So there's a decent amount of calculation going on to find out, okay, how long should it take to break this block. The bot even handles enchantments. If I have him give me the pickaxe back, I'll enchant it really quick. That should do it. And then give it back, and you'll see it moves much faster now. This server is running the vanilla Minecraft server, which means this bot has to move and break blocks in a certain way, or else it'll get kicked. So I've written it in a way where it acts pretty similarly to how a normal Minecraft client would function, but obviously there's no actual client. It's just the bot. I've switched the server to offline mode and spawned in a couple bots. My bot program doesn't just work with one bot, it can manage multiple. I mean, in theory you could run an infinite amount, but realistically, because I still have to handle loading chunks and networking for each of the bots, my computer can maybe handle 10, 5. 5 is a reasonable amount. In the future, I'd like for the bots to all share the same world and stuff like that on the software side of things. But right now, that's just not feasible. So I'll move all the bots over here. And we're gonna have them mine out the side of this mountain right here. I should have given them some shovels, so let me do that really quick. I'd like to have a better way to manage their inventories in the future, maybe just place down a chest and then, instruct the bots to take items from there, but right now, interacting with chests is extremely complicated, and so it's just not something I have time for yet. So this side of the mountain right here that I've got marked out with these concrete blocks, this is a pretty common situation I think you would encounter with bots where, you could in theory mine this all out yourself, but I mean, who wants to do that? So that's what the bots are for. I had to restart the bots. Had some bugs to fix, which just kind of shows how much stuff is going on in the background just for something simple like walking to a location and breaking blocks. As you can see, now that we're getting closer to the end, we're getting lots of missed blocks. This is a bit of an issue. Up here, these artifacts over to the left, you'll notice for the most part they're over on the left side. I think that's because, as they walk over to this side and they mine blocks under themselves, they have to fall. And I think the server is rejecting certain block breaks. Maybe as they're falling, they're trying to break blocks. I've added some locks to the thread that handles movement, but we're still getting these missed blocks. And then obviously here at the end, it gets really bad. I think it's because a couple of the bots, their tools broke. And so these are all issues that, I'm just gonna have to keep working through. Because there's so many things going on and because this information is sent in between the server and the client asynchronously, it's a very unique debugging challenge. But this is, considerably better than it was at the beginning, so I'm happy with the progress. While I've definitely gone overboard on implementing features for the Minecraft bot here, the original purpose of this project was for my artificial intelligence class, and so in some way, I need to implement artificial intelligence with this bot. Now, I didn't just want to force something that wouldn't actually be useful, so I needed to find an actual problem to solve. Like, in theory, I could just have the bot figure out a path randomly, a path with AI, but there's no need for that because, it can all be done with A* already. But while working with the bot, I did come across a problem that works perfectly with AI, and that's the ordering of block breaking when it comes to like what you're seeing right now, farming. The problem that I'm having is, as you can maybe see, the bot's path isn't really optimal. He's just doing the blocks in order from Y position, then X position, and then Z position. So he's just going up and down rows, breaking blocks. Now, this is okay, but I definitely want to improve the path. And this is a pretty classical problem in computer science called the traveling salesman problem. And so I decided to use an evolutionary AI in order to solve that problem. Now, right now, it works with just a single agent, but I want to continue to develop it and allow it to optimize paths for multiple agents, which I think will be the most impressive thing technically and just the most fun thing to watch, watching 5 bots all take, a semi-optimal path through the farm. So what you're watching right now is the bot using the old method of farming. And he's just finished. And so now we'll try using my evolutionary implementation to grow a couple crops. And we'll stop that again. And now let's reconnect with the bot. And give it some time. It usually needs a little bit to load in all the chunks. That stuff's sent for the server asynchronously, so it's kind of hard to know when it's actually done. I usually just give it a couple seconds and then you can start interacting with the world again. So we're printing every 100th epoch here. The starting score fitness for the path, so the original path where it'd be zigzag, is 38,000 here. And you can see the score is lowering. And it looks like it gets to 21,000, which is considerably better than the original path. I mean, there's still a lot of room for improvement there, I think. But you can see, how the path is being improved here. Even though to us, it might seem like the bot's kind of zigzagging around. It's definitely faster. So let's look into that fitness function and see how it works. So right here in this handle farm, which handles the farm command down here in the interface, we are parsing the positions, the 2 corners of the farm, and then we loop over the range in between those 2 positions and filter it to only get farm blocks, so only carrots, potatoes, the kind of thing we want to farm. And then if we pass in the AI flag, which means that we want to have the path optimized, we create a new population of size 100. We optimize or evolve the population 1,000 steps. And then we, take the best path out of that population and use it. So let's look into how that AI is working. Over here in this evolution class, we have kind of the abstract representation of what, some sort of problem that can be evolved. So here's an individual, which just represents a single individual in any one of those evolutionary populations. Individual is the best name I could come up with. It's a bit verbose, but that's fine. So the 3 things an individual needs to be able to do is have its fitness evaluated, to crossbreed with another individual, and to have a mutation applied to it. And then a population is just a collection of those individuals that can be optimized. And that's what this evolve function does here. So the pathfinding implementation of this, we have a pathfind individual, which has a path and a list of positions. So this is just a performance optimization I did, where the actual path that is being copied isn't a list of position objects, because it's kind of slow for Python to copy those. We have kind of a master lookup table, and then the paths are just a list of integers which represent keys to that lookup table. It's not super important. It's just for speed. The really important things are this fitness function, and this is the main thing that I think in the future, making changes to this will allow me to improve the quality of the paths that I'm getting out of the bot. So right now what I'm doing is I'm taking the Manhattan distance between the 2 positions and I'm squaring them. The reason I'm squaring that distance is I'm really trying to punish big differences between blocks. If there's a 1 block difference, from one position to the next, I want the bot to prefer that. And the bigger the distance is, 9 block jump, even if that leads to a better path, it looks less natural. So I want the bot to always prefer to break blocks nearer to itself. I'm not sure if this is something I'm going to keep in. This fitness function is really important for kind of changing the kinds of paths that we get. The reason I'm taking the negative is because this whole API that I wrote, it is trying to maximize a function, and we're trying to minimize the distance, so I just negate it here. This breed function, what it does is it takes a crossover point, and then it swaps between the mother and the father, but then, and this is really hard for me to demonstrate. If I were a graphical artist, I would make some sort of visual right now, but basically when I swap over the end of the mother and the father's paths, sometimes we get duplicates, and so this right here is for resolving all of those duplicates, so that the paths stay valid. We can't visit the same point twice, and we can't have points removed from the path. They all have to be valid. And then this mutation function just takes in a rate and swaps random positions that many times. So I think the rate that I'm using is 10. So that means every time a new child is created, 10 of its positions are swapped randomly. And the fitness has to be recalculated after that change is made. The fitness is calculated twice. This is another optimization. It's calculated on creation of the thing, of the individual, and you can see that here. And it's calculated in the mutation function after it's mutated. We don't need to do it in the breed function because it creates a new individual, and so the fitness is recalculated there. And then what the pathfinding population needs to do is be able to build random paths, which it does here. We just shuffle our list of paths and return individuals, and then everything else is handled by the evolution API. The good thing about the way I have the API set up is I can apply this to a lot of problems. So not just pathfinding, but maybe in the future I want the bot to be able to craft things, and it might allow me to choose different priorities between what I craft first and what I craft later. So let's try making a change to the fitness function and see how it affects the bot's performance. So we're going to remove that square that I had from earlier on the fitness calculation. So now we're just summing all the distances between the points in the path. So let's see how that affects everything. So we'll spawn back in the bot, and let's take a look at what he has to farm, and then let's tell it to farm and see what happens. So the total distance starts out at 1400, and you can see we're optimizing. We've taken 400 off the total distance. Not a massive improvement. You can see it kind of reached, I don't know if this is the local maximum or a global maximum, probably not the global, but I mean it's still a significant improvement in terms of distance. So now we can see the bot is going. It's kind of hard to compare different fitness functions because the scores aren't really comparable. This score of 1400 doesn't really compare to the squaring scores because I don't know, there's not a good way for me to normalize those. So I think in the future an improvement that I can make on this so that I can further tune the population parameters is some sort of timing to see, okay, how long does it actually take in the world for the bot to carry out all these actions. One one of the big problems with the fitness function is that it's a pretty big approximation. It's just a summation of all the distances between the different blocks in the path, but the reality is that the bot doesn't move all the way to the position. It just moves close enough to break it, and then it continues to move. So the like here we'll see the pathfinding makes the assumption that the bot's going to walk here and then it's going to walk here, but in reality if the bot stepped here it could break both these blocks without having to move, which would be pretty fast. So in the future, an improvement I want to make is, you know, a more realistic fitness function, but I'm not really sure how I'm going to do that performance wise. It's not really feasible to spawn in a bunch of bots for every generation because there's just so many and there's so much overhead involved in spawning in a bot. You know, handling the world and all that adds a tremendous amount of overhead to the program. So I can't really spawn in more than 5 to 10 bots at a time, which would mean that optimization would take days, which isn't really very useful in an actual situation. So I am thinking about maybe simulating the world somehow in the fitness function, but even that, I mean, I've done some profiling on the program, and the fitness function is being called hundreds of thousands, if not millions of times, and so I'm not sure how I'm going to, you know, simulate an entire world that many times, especially the pathfinding and stuff like that. So these are things that definitely need improvement and need more fine-tuning. But right now, the kinds of results I'm getting, I'm very excited to see the bot, you know, has a pretty good understanding of what's closer and what's not. You know, see, it broke these two blocks right next to each other. It finds little groups sometimes. Well, that's a bad example, right when I want it to. Yeah, let's see. Yeah, it kind of stays in the same regions. You know, we can see from the fitness that these paths are at least better, but they're certainly not optimal. So that just about covers everything with the bot. You know, it has some other features. Right now you can see it hunting, a couple other little things, but that covers most of the major stuff. It's been a really fun project, probably the most enjoyable school project I've had in my life. And I'm really excited to keep working on it and to keep improving it.